All right. Yeah, quick introduction. Chuck did most of it already, so thanks for that. So I'm Thomas Vissers. I'm an engineering manager at Cloudflare. I work on API security and on the API Shield product at Cloudflare. And so we use these, the things I'm going to talk about today, we use these on our own API. We have api.cloudflare.com, where our own APIs live, but we also help protect customers. So we try to apply these strategies in both scenarios. So we're going to talk about automatically generating a positive API security model. And the sort of catchphrase here is to watch and learn. And we'll get into that as we move along in the presentation. So I'm going to kick us off with an example API ecosystem. And your API ecosystem might be a bit different, but I think the same principles will apply. So let's start off with maybe the most important component, the backend, right? So we have multiple APIs here running in our API ecosystem. And the message I want to convey here that these are typically very heterogeneous. You might have a multi-cloud setup, you might have some on-premises APIs, some in the cloud, you might have different technologies, and they're being developed by different teams, right? Maybe spread across the globe. So very heterogeneous environment where these APIs are being deployed. And then you might have something like an API gateway or similar tool to help you manage those APIs, help you route the traffic to that backend, and hopefully also help you put some security in place. On the other side of the API ecosystem, we have our consumers, the users of your APIs. And this is also very diverse. Similarly, as in the backend, you have your internal users, your administrators, your developers consuming your APIs. You maybe have a web application that is consuming those APIs, a mobile app as well, fetching data from those APIs. And then maybe you have a customer that has a server that is querying your API, is paying a lot of good money for your great product that you're running on that you're exposing to your APIs. And then last, but unfortunately not least, is the malicious actors, right? So these are the people that are trying to abuse your APIs, that are trying to compromise your systems. And as this is an API security talk, this is, of course, the flow that we're going to try to minimize here. So we're going to talk about some ways to secure that. And we're going to talk about two examples today. There's many other ways to secure APIs, but for the sake of the example, we're going to stick to two. One is rate limiting, and one is schema validation. Rate limiting, probably very familiar to most of you. In rate limiting, you are essentially defining within a certain time window, a user can consume your APIs at a certain rate, right? Let's say this user can consume this API 5 times in a minute, and if they exceed that, they will be rate limited. Okay, good. We'll set that up. Then let's talk about schema validation. This is a bit more interesting and more powerful, and this is where the positive security model also comes into play. Here you'll use, for instance, an open API specification of your APIs to harden really what can go through, what requests are allowed through to your API backend, right? So that open API specification can define for each API endpoint which parameters are defined there and what their data types are. So if you're then trying to send some sort of weird injection string to a field parameter that's supposed to be an integer, for instance, then that will be blocked by the schema validation. Very powerful tool. Okay, so great. We have our API ecosystem. We have security put in place, this static security configuration, and we're keeping the malicious actors out. That is great. But then comes change. So let's say there is a new API endpoint being deployed, or as we saw earlier, for those who were around here, there might be a zombie API endpoint that we don't know about. Then there might be some team that changes one of your APIs. They change one of the parameters, right? They add a new parameter. They add a new feature to the API. Let's say they add pagination to it, and now there's a new parameter suddenly popping up in that API. And then on the consumer side, things are also always changing. That big customer of yours that is paying you good money for your API, they're doing great, and they tripled the number of requests they're sending you over the last week. So what all this change does is it weakens and often even breaks the static configurations of your static security configurations that we have put in place. If we think about it, for instance, that customer that's sending 3 times as much traffic as it was before, they will now be rate limited by you because the usage pattern has changed, and your rate limit did not take that into account, and now they're getting blocked, and it's legitimate traffic, right? That API endpoint that wasn't there before, or that we didn't identify, that zombie API endpoint, that is not getting any security at all, right? It's not even, it's just receiving traffic from the public internet, not going through your API gateway, no rate limiting or schema validation set up. And then there is that endpoint that had a new parameter. Depending how you've set up the schema validation, that will actually result into all legitimate requests being blocked because the schema validation didn't know about that new parameter, or best worst case, depending on how we look at it, the new parameter is just not getting any coverage in the schema validation. So that's the reality that you're actually dealing with in most cases. So the main question I want to answer today is, how do we secure these ever-changing API ecosystems, and how do you keep those positive security models up to date? And the main strategy here is watch and learn. So we will continuously be watching your API ecosystem. Observability is key here, and we will derive learnings from that and automatically plug that into our security configurations, automatically update the security configurations to make sure that you're in tune with how your API ecosystem has evolved. So we assume that the only constant is change. Now, let's put that into very practical examples. The first one is discovering new endpoints. What you can do is you can tap into your request logs, and not the one of the API gateway, but the one, hopefully, load balancer or reverse proxy in front of that receives all your HTTP traffic from the public internet. And you can look into that API, into those HTTP request logs, and you can try to find new endpoints. And you can use an API discovery service for that. So essentially, what it does is, in a simplified version, you have your HTTP requests. We're only listing the path here for brevity. And what you need to do is you need to use some heuristics or some data science entropy techniques to make sure that you're able to derive the path variables. That's the tricky part, I'd say. So here, the variable parts. So one is a name and one is an item number. If you're able to derive that from the request logs, you're able to derive all the endpoints that are actively receiving traffic today in that very moment. And if you then have a service that can simply diff that, take the delta with what's in your API gateway with your current security configurations, you can very easily find out, hey, this endpoint is receiving traffic, and I didn't know anything about it. So going back to our example, on the top right there, that new endpoint, suddenly our API gateway will get pushed a new security configuration from that endpoint that we have discovered automatically. Great. Let's dive into the next example. Adaptive rate limiting instead of just rate limiting. And here, we also look at request logs, but here we can just take the request log from the API gateway if that's easier. It doesn't really matter. And essentially, you just have to come up with a database that for each endpoint tracks how many times is this being queried by, let's say, a session, or depends on what the granularity is you want the rate limiting to operate on, but how many times is it being queried every 5 minutes, let's say. And you just keep track of that constantly. And what you're able to do then is you can basically plot the distribution, right? So x-axis would be number of requests in 5 minutes, and the y-axis would be the number of sessions that are actually doing that. And I can tell you, it doesn't always look as normally distributed as this graph. But if you have those distributions, you can then use, again, simple statistical methods to derive a meaningful rate limit based on your security appetite for that endpoint. But the main point is you can plug in that formula into your database and then push it to your rate limiting. So however the usage patterns change over time, It doesn't matter. The system is taking care of it. The system is making sure that the changes in the API ecosystems are reflected in your security configurations. So again, here this applies to the change on the left, where a customer tripled its number of queries over the past few days. They're now not being rate limited anymore, as we have adjusted our rate limits to take into account that new reality. And the last example, perhaps the most interesting one, is the endpoint that had a new parameter. And for this, you can use parameter schema learning. And the pattern here is the same. You take a look at your request logs, and you look at all the query parameters. We'll stick to query parameters, but any sort of parameters in the API work the same way. You look at your query parameters, and if you have a lot of those requests, like I'm only showing 3 here, but if you have thousands and thousands of them, you can very confidently infer for each key and value what the data type is of the value, right? Here we see 3 instances of the user being an integer. And if you have 10,000 of those, you can very confidently say, okay, that user parameter in that API/by endpoint, that's an integer. And you can generate a schema from that, and you can push that schema into schema validation automatically. And you complete the cycle, and you automatically update the security configuration. So success, even that last situation we've tackled, and we have all 3 scenarios constantly being in tune with the changes to the API ecosystem. And that's maybe when the fun starts. When you actually have implemented those watching techniques, basically you're really good at observing all those changes, all those requests to your API endpoints. You can even enable more advanced security features on top of that. And one of them is something that we do is called sequential anomaly detection. So essentially, we look at the behavioral patterns that we see. A session always queries APIs in a certain order. If you see on the left here, in an e-commerce site, that might be, the first query might be to add item. The second API call will be cart. The third one, checkout, and then pay, and then confirm. And if you look at the data, you would never see a confirmation without a pay call before, right? And we can use that to derive transitional probabilities. As you can see on the right here, you can say, okay, we are likely to go from pay to confirm. That happens in 90% of the time, but we never see from checkout to confirm immediately, right? And so we can say this is an anomaly, and you can block that. So once you have all these request observability in place, you can come up with these very clever models that capture the normal behavior on your API ecosystem and start blocking against things that deviate from that. All right, to conclude. So static security configurations do not work. Your users change, your developers change, your infrastructure changes. That's guaranteed. So what I'm proposing here today is to continuously watch your ecosystem, and it's mainly achieved by having proper request logging and being very clever about how you look at them. And then you can learn from those logs to, for instance, find new endpoints to secure, find new parameters for schema validation or adjust parameters in there, find new usage patterns so you can plug it into adaptive rate limiting, and establish a sense of normal behavior to start blocking things like anomalous sequences. And that continuous learning, you can harden your APIs by automatically updating security configurations. All right, I'll stop here. If you have any more questions, I'm around here, or you can hit me up on LinkedIn or email. We also have a booth here to stop by with the other colleagues I'm here. So thank you much for your attention.
All right, thank you, Thomas. Any questions for Thomas? Yeah. Big steps again. Here we go.
So, very interesting talk. Can you tell me where this kind of log learning is enforced and in place? In what what products, or is it still in R&D, or is it in production, or?
Does it work? Okay, so we have a product called API Shield, and we have API discovery. We have recently launched the schema validation feature. So these features are actually live and ready to use for people.
So Tom, I have a question. So with respect to zombie APIs, where attack surface is exposed, but they're not currently being used,
Right.
how is Cloudflare thinking about closing that blind spot, right? Because if there's no traffic, you're not going to see it at the CDN level. What are your...
Right. In its current state, we're doing passive monitoring, essentially, right? That enables us to detect APIs that are actually actively being used, right? For APIs that are just lying around and nobody knows about them and nobody's actually using them, you need active probing to make sure that you do that. So we would need an active probing feature to cover that. But we are solely relying on the logs and the stuff that's actually being used, and we think that covers a lot of the zombie endpoints already. But definitely, active probing can help fill that last gap for sure.
Yeah, for sure. And code analysis as well.
Yeah.
Enumeration actually in the code, but if it's not your code, if it's a third party,
Exactly.
the APIs are just hard to find sometimes. So.